Okay, well, hello everyone. I guess we'll get started here. So, welcome to the Forestry Adaptation Community of Practice webinar today. For those of you who don't know me, my name is Annette Morand, and I am the facilitator of the online adaptation communities of practice. And those are run by us here at OKR, which is the Ontario Centre for Climate Impacts and Adaptation Resources. And we're located at Laurentian University in Sudbury, Ontario. So the way the webinar will run is as follows. So after this short introduction, we will have the main presentation, and that will go for about 40 to 45 minutes. And then at the end of the webinar, we're going to have some time left over for any questions that you might have for the presenter. So if you have any questions during the webinar, we just ask that you please hold them until the end. Before we get going, I just have a few housekeeping items to go over. So first, for those of you who dialed into the conference call line, your lines have been automatically muted. And the reason for this is just to avoid any audio distractions, feedback, etc. during the webinar. So to ask a question during the question and answer period, all you're going to have to do is dial *6 and that will unmute your line. But please do keep your lines muted during the presentation. Also, you'll notice that there's a chat box on the left-hand side of the screen. You can use this chat box to field any questions that you might have for the presenter during Q&A. As well, if you have any technical difficulties during the webinar, you can also use this chat area to type your message, or you can actually click on my name and send me a private message, and I can try to help you as best as I can. I also want to mention that we are recording the webinar today. I'll be sending out a copy of the recording to all of those who have pre-registered with me, and we'll also be posting it to the Community of Practice website. And finally, I know we have some people on the line today who may not be familiar with what the Forestry Adaptation Community of Practice, or the FACoP, actually is. So I just wanted to take this opportunity to quickly mention that it's an interactive online community. It's dedicated to those who are working in forestry or those who are simply interested in forestry and climate change adaptation in Canada. And it includes features such as news articles, events, an online library, discussion forums, and much, much more. So it's free to join. So if there's anybody on the line today who's interested in learning more about the FACoP, please click on the link in the chat box for more information and to register. So with that being said, we are very excited to have Dr. Isabelle Charron on the line with us today to talk about a guidebook on climate scenarios, how to better understand climate information. And just so you know a little bit more about your presenter, Isabelle holds a doctorate degree in forest ecology from the University of Calgary and a postdoctorate degree in fluvial geomorphology from the University of Montreal. She joined Uranos in 2010, where she is part of the Climate Scenarios and Services Group and has contributed to a large number of vulnerability, impact, and adaptation projects, such as authoring an atlas of climate scenarios for Quebec's forests and evaluating the impacts of climate change on different sectors, so ranging from the maple sugar industry, the Canadian energy demand, and northern ecosystems. Most recently, she was the author of this guidebook on climate scenarios for decision makers, which we will learn more about today. And she participated in the preparation of Uranos' Synthesis on Climate Knowledge in Quebec, both published in 2014. So on behalf of everyone joining us, I'd like to extend a very warm welcome to you, Isabelle, for taking the time to present this webinar for us today. It's very much appreciated. So without further ado, I will now turn things over to you.
Great, thank you, Annette. So hello, everyone. I'm quite happy to be able to present this guidebook to you today. In the short time that I have, my goal will be to really give you an understanding of why we produced this document, to briefly go over some of the main sections of the guidebook, and to give you a sense of the messages that we tried to convey to the vulnerability, impacts, and adaptation community. Before I begin, I want to mention that this project was funded by Natural Resources Canada through their adaptation platform. So the motivation behind producing this resource stems from a number of different factors. First, at the core of all of this is really the fact that the demand for climate information is ever increasing, and we simply cannot have one-on-one interaction with every user. And so we're trying to promote or increase the capacity of users to understand climate information. We want to establish, first of all, a common language with end users. We also want users to become more critical and better at evaluating the climate information that they are provided, and also increase the transparency and responsibility of climate service providers when they produce information so that we can facilitate that transfer with users and increase the trust between users and producers of climate information. So the guidebook really is meant as a complementary resource to the rapidly expanding body of literature of documents dedicated to climate change adaptation. Many of you will recognize the steps listed here, which describe a typical adaptation framework. The guide essentially focuses on the third step, which is to understand climate, either the past or the future. This is a critical stepping stone in the evaluation of impacts and the development of adaptation measures. However, we feel that at this time, users are still given little guidance in terms of the type of climate information that they should use, and so that is really the gap that we are trying to fill with this guidebook. So the guide is really meant as a knowledge transfer tool from climate service providers to users of climate information, with the objective of helping decision makers have a better understanding of climate information so that they can increase the capacity to use that information in an adaptation framework. There are a number of key messages that shine through the information given in the guidebook, and amongst them, the most important ones are the fact that, first of all levels of climate information can be equally valuable. By that, I mean that detailed climate information is not always necessary to make decisions in terms of adaptation to climate change. Second, there's no such thing as a best climate scenario. We promote the use of an ensemble or a range of plausible futures that should be considered when making decisions regarding climate change. Third, it's important to understand that the same climate information can be tailored or presented using different formats. This may seem mundane, but it's actually far from being insignificant. The way in which the information is presented, think of a table or a map, for example, will speak differently to different users. And this tailoring can be important enough to influence whether the information is understood or whether it's or not. So the guide is really written in a very general fashion in order to reach the largest variety of users with different levels of expertise and from various sectors of activity. That said, it's obvious that the guide will be most beneficial to those with relatively little experience with climate information. So for example, if you're used to handling climate data sets from climate stations, or if you have been playing around with climate model outputs for a while, this resource might be a little bit simple or too simple for you. The guide is clearly aimed at the vulnerability, impacts, and adaptation community. However, climate service providers may also benefit from some of the information provided in the document, in particular in terms of how to categorize climate information and how to help users identify their climate information needs. We want users to become more familiar with different types of climate information and become, at the same time, more critical of the information that is given to them. So with these brief objectives in mind, I'll move on to the core of the guidebook, which is really to try and help users understand how climate scenarios are constructed or produced. So as climate service providers, we make a number of inquiries to determine what the most appropriate information should be provided. Questions ranging, for example, regarding the purpose of the information. So what is the information going to be used for? What climate variables or indices are of interest? How much data can be assimilated by a user? What are the spatial and temporal scales over which the information is needed? So what I have done in the guidebook is really expand on these questions to come up with a roadmap in a form of a decision tree that guides the reader through a series of questions regarding these questions that you see here so that they can better evaluate their own needs. So the decision tree looks like this. Don't be scared. I know it's quite small and I don't expect you to be able to read this on your screen right now. What I want you to take away from this is that the reader, as he goes through this decision tree, will find himself into one of three broad levels of climate information categories: basic, intermediate, and detailed. So the categories are largely based on three main criteria, namely the purpose of the information, the climate index of interest, and the spatial and temporal scales over which the information is needed. However, other factors also come into play, such as the amount of work needed to provide the information. So that's on our end, how much work we need to put into providing the data, the amount of support that must be given to a user in order for them to use the data, and even the amount of uncertainty associated with the data given. So there are a large number of factors that will influence whether you're finding yourself in one or another category. So if I try to explain a little bit more what the categories detail, here you have a table that is showing you examples of goals or purposes, so one question out of the entire decision tree for each of the different categories. For example, basic, you can be wanting to just generally raise awareness about climate change. So will there be, for example, a temperature or changes in precipitation in my region over the next 50 years? In the intermediate category, you might be able to do an impact study or vulnerability assessment. So here we're going more into detail. So for example, how will productivity be affected by changes in temperature or precipitation? And the detailed category, we're dealing more with either evaluating adaptation measures or doing some sort of research and development on key variables that are less well known, for example. So here, what type of measures must be put in place to limit the damages to increases in freeze-thaw cycles, for example. So what's important to remember here is that you're only looking at one question out of the decision tree, so the purpose. So here you have adaptation measures in the detailed category, but I told you at the beginning that this may not always be the case. So you can find yourself in the basic category, even if you are trying to evaluate adaptation measures. The same thing can be true. So you can be doing research and development in the basic category where you're looking at a variable for which we have little data. So think of, for example, wind or freezing rain. So the amount of uncertainty around those variables is quite large, and so you would typically find yourself in a different category if you're looking at those variables. So once a user has identified one category, he's then oriented to different types of formats that would best suit their needs. So the idea here, again, is to showcase the same information but present that information differently. So think of changes in temperature, for example. So as you move from one category to the next, there's a general increase in the complexity of the variable or index of interest, as well as a general increase in their resolution and often the amount of information given. So we wanted to show in the guidebook as many common formats as we could. So here you have an example of about 5 different formats for each of the different categories. So I'll give you an idea of what those might look like in a second. So what we're really trying to do here is reconcile 2 points of view. So how the user views climate information and how, as climate service providers, we view the information. So for example, on the user side, as you move from the basic to the detailed category, you'll have users that generally have little experience with climate information, that have simpler needs. They may have more of a qualitative use of the information versus users in the detailed category that have more expertise and are using the data in a more quantitative fashion. From a climate service side, we tend to think of the basic category as information that's easier to produce and perhaps easier to explain, whereas the detailed category will take us perhaps more time, so more difficult to produce and perhaps more difficult to explain. But in reality, that's not really the case, because the information that we provide to a basic user, we're giving information to a user that has never used climate information before in many cases. So it's actually harder for us to explain, and the amount of support that we have to give to that user is actually greater than the information that we provide to a detailed user, who is often very used to dealing with large data sets and lots of climate information. So those kinds of ideas that we're trying to reconcile. How do we view the information? How do we prepare the information for different users? So what we do next in the guidebook is really go through each of the formats in more detail. So we show how we tailor the information, and here we try to explain to users how to understand different formats and how to become more critical of the information that they are given. So this section is very much set up like a catalog where we go over each format in greater detail. So you have an example of how that is set up in the guidebook here. On your left, you would have the actual figure or format, and on the right, you would have the explanation associated with that figure. So the text associated with each figure is divided into 4 sections. One that will explain what information is provided in the figure. A second section will explain how the figure is constructed. A third will explain how to interpret the information that is given in the figure. And finally, a 4th section will explain some of the limitations or possible ways to misinterpret or to misuse this information. Along with that, we also use bold colored fonts to highlight some key climate modeling concepts that may require some additional information. So these concepts are explained in a later section of the guidebook, so think of that section as an expanded glossary. And here we really try to go over concepts that our users frequently ask us about. So explaining climate models, climate scenarios, emission scenarios, explaining why we, for example, from using ESRA's emission scenarios to RCPs. Why do we need to use an ensemble of simulations? What are the different sources of uncertainty, etc.? So we try to go over each of these concepts in more detail so that the information in the figure is better understood. So I want to take a minute now to go over some of the different examples that we have in the guidebook for the different categories to give you an understanding of what I mean by tailoring the information for different users. So in the basic category, you'll often find fairly simple climate variables. So think of temperature and precipitation, for example, where we're averaging changes over large spatial scales, over large temporal scales, and this type of information is arguably the one that is most easily accessible via websites or summary reports, so users are typically more familiar with this type of information. So the example shown here is a synthesis table, which outlines the projected changes for a number of different climate variables for the province of British Columbia for the period 2041 to 2070, so the horizon 2050, in relation with a reference period of 1969 to 1990. So an important point that is addressed in the guidebook for this category is the fact that when we present changes, we present changes between 2 climate simulations, so a simulated past and a simulated future, not the difference between a model output for the future and true observed values for the past. So this concept is often one that is a little bit confusing to users. Also notice that even for this type of information, so the basic category, we show a range of the projected outcomes. Here we show a median along with the 10 and 90th percentile changes. So users have to get used to the fact that are being provided with a number of plausible futures, not just one best single scenario. So in the basic category, you also have examples such as maps. So I've shown you, for example, changes in temperature over here. You have changes in temperature over all of Canada on this map. So again, looking at one specific time horizon. So here we're looking at a 2071 to 2100, so a little bit further into the future. One variable over a large spatial scale. So again, you're shown the median along with the 10, 50, and 90th percentile. And again, the changes are obviously calculated between a simulated reference period and a simulated future. So this type of information in the basic category is often one that is easier to understand, particularly tables, which are a very common way to present information in different sectors of activity. The information also provides a very general, rapid overview of what is projected for a given time period for a given region. So the information can be used by a large variety of users. In terms of the limitations or the pitfalls, one has to remember that the changes are averaged over large areas. So these large-scale averages may not always adequately represent changes over a more specific, smaller area. In addition, while the changes are given for a specific time horizon, so say 2050 or 2090, users have to remember that the changes obviously may not occur abruptly on 2050. They're more gradual than that. It also may not mean that you will not have years that are in opposition with the overall trend that you're seeing here. So a good example of how this information is used, I borrowed this from our colleagues at the Pacific Climate Impact Consortium, who provide this type of information on their online tool. So they will use the maps and the tables, for example, to give a general sense of what may be happening for different sectors. So for here, I show an example for forestry where you're talking about shorter snow seasons, so less snow on the ground, which will impact the logging activities, for example. So you get a good general sense from this type of information of what needs the most important impacts for your area and your sector of activity. Now, if we move on to the intermediate category, this category will also include not only temperature and precipitation, but we're starting to derive climate indices from temperature and precipitation. So think of growing degree days, frost-free days, for example. The resolution and the scale of information is also becoming more specific. So in other words, information that is becoming more tailored to specific use. So what you're looking at here is a spatial analog. So I don't know if you can see, I'll try to point it out with the arrow. So you have a hatch. Can I grab the arrow?
Oh, you just have to hold down your mouse button. There we go.
Oh yeah, there we go. Thanks. So the hatched area here is a black spruce stand in the boreal forest of Quebec. So what you're looking at here are regions in green where the recent climate, so the climate from 1971 to 2000, is what is expected to be the climate for that region in 2080, so 2071 to 2100. So you're looking at future, where the climate of the future is currently for that region. So the analysis here is based on annual temperature and annual precipitation. So I showed you examples before of how we present precipitation and temperature in the form of a table or a map. We're showing exactly the same two variables here, but in a vastly different way. So climate analogs are arguably one of the formats that speak the most to users because it's very visual and it draws on current experience. So it can be a very powerful tool to explain projected future changes. However, there are important limitations associated with the way analogs are constructed that must be appreciated before this data is used. For one, the analysis is often solely based on a few climate variables, here temperature and precipitation, so it therefore may not represent the whole climate. Here, as an example, if I can hold this again, you can't see the name right now, but Baie-Comeau is a small town right on the coast here of Gaspé. So Baie-Comeau is actually an analog to our black spruce forest according to this analysis. But you can imagine that Baie-Comeau being right on the coast will experience climate characteristics that may be vastly different from those that will be experienced in that black spruce stand of boreal forest. One also often assumes that the two regions share non-climatic variables, which may not be the case. So think of soil type, topography, which will have important impact on biological processes, but are not taken into account here. So caution has to be applied when comparing analog regions and using this type of information in a climate adaptation setting. However, having said that, the spatial analogs have been particularly useful to compare both the impacts and the adaptation measures that are being put in place in different regions. So for example, by finding a climate analog, you can identify potential impacts. Here I use an example of a disease, or a pathogen that is already occurring somewhere else, and you can start looking at how the people over there are using different adaptation measures to face that problem in the analog region, and then evaluate the potential transferability of those measures in your region. So it's a good first-hand look at what is being done elsewhere to deal with problems that may be coming for your region. Finally, for the detailed category, now we're dealing with information that is provided typically for a very specific use, and information that is typically not of little use to someone else, so quite tailored to one use. So I present here an example of temporal data series which are given to users. So in other words, we're giving raw outputs from climate models to a user. So say one or many climate variables over a number of days, years for a given region, and this data is then used to run an impact model and to look at what the impacts of climate change may be on a system or another. So what you're shown here in this figure is an example where climate data was used to run an impact model to evaluate the impact of climate on maple syrup production for one particular region in Quebec, so the Beauce region. So obviously there are many advantages to having the data itself. So the data, given that you are in charge of the data, you can do whatever you want with it. The data is not necessarily complex either. Here, what is important to remember is that the amount of data is typically significant and will require a certain amount of expertise in dealing with these large data sets in order to use it. So in addition, while you're giving all of you're given all of this data, you also need a very good understanding of the system. In this case, it was the physiological response of maple trees to the climate and of the limitations of the climate data itself, because you're just now in charge of calculating all of that on your own. You often need additional complementary information that the climate service provider may not be able to give you. So in this case, what needed to happen first was that while we were providing climate information to the biologist in charge of finding the impact on maple syrup production, we first needed to decide on which climate variables were going to be most important to actually come up with the impact model so that we can then project what would happen in the future. So there were many steps that needed to be taken in this example. And so finally, another limitation is that the transferability of this type of information is limited, meaning that the information that we are given is for a very specific area and it's going to be very difficult to transfer that to another region. But having said that, the detailed information is often used for essentially every single purpose that we pointed out at the very beginning. So for example, here, the maple syrup example is a good example where we were doing research, so trying to establish first a relationship between the climate and the maple syrup production. Also then trying to evaluate the potential impacts of climate change on maple syrup production for a different region in Quebec. And it also allowed us to begin a discussion with stakeholders, so maple syrup producers, regarding potential measures that could be put in place to limit the impacts on their industry. So quite a lot could be done with that type of information. So to conclude, I hope I've shown you that this guidebook is really a new novel tool for the vulnerability impact of adaptation that hopefully help them in their adaptation work. The guide presents a unique way of categorizing climate information so that users can better evaluate their own needs. And we're really not trying to form experts here. Our hope is really to bridge the gap between climate service providers and the user community. We hope that to show that certain type of information can be given to a user, and they can essentially run with that information and understand what climate impacts will be in their particular issue. But there are other types of information, more, for example, in the detailed category, where there's going to be more of a longer dialogue, closer relationship established between the user and the provider of information. Ultimately, we want climate information to not only be understood, but also be used in an adaptation framework. So I thank you for being on the call today. I will leave you here with the links where you can download the guidebook in either French or English, and also mention that we're currently involved in a promotional and testing phase of the guidebook with Natural Resources Canada. So if you have any comments about the resource, or would like to participate in a survey about how you use the guidebook, please do not hesitate to get in touch with me. We're really hoping to have an updated version of the document in early 2016 with all of the comments that we will have received from users. Thank you.
Perfect. Okay, great. Thanks, Isabelle. So we have lots of time for questions. So if you have any questions or comments, now would the time to ask. So again, if you'd like to use the chat box, please feel free to go ahead and type out your question. And if you're on the conference call line with us and would prefer to ask a question over the telephone, all you're going to need to do is hit *6, and that will unmute your line. So we have a question in the chat box from John. So he writes, any general studies, for example, hydro generation across Canada?
So we showcase in the guidebook a few examples of how climate information has been used, but we don't have a specific one on hydro generation. I have been involved in different studies on energy demand in Canada, so I can share with you what has been done in that sense. But there isn't anything particularly on that topic in the guidebook.
Okay, perfect. Thank you. I see some other people typing, but I guess I'll go to the conference call line. So if there's anybody that would like to ask a question over the phone, just go right ahead. Give everybody a few seconds here. Okay, if not, I'll come back to the conference call line soon. So Joe has a question in the chat box. So he writes, I think I understand why you compare simulated past to simulated future scenarios, but do you ever compare the simulated past scenarios to actual past data?
We'll do that in a more qualitative fashion. So we will give users actual observed. So for example, we'll have a map of actual observed value, and next to that we'll have a map of future values. So you can qualitatively compare true values with what's being simulated out of a climate model. But the reason why we don't do that when we actually prepare the map to show the change between past and future is that the climate model response is always biased. So first of all, we have to choose models. So one model will respond differently to different emission scenarios and will have its own strengths and weaknesses. So we hope that each model represents the true observed as well as it can, but they don't necessarily. And so if you use one model, for example, that has a very strong cold bias, and you compare the output from that model with true observed, you're not getting the right response. You're not getting the right change between past and future. So you have to use the same model and remove that bias between the past and the future. Does that make sense? Does that answer your question? Hope.
If not, I'm sure he'll write again. Oh, there we go. He says yes. So Jenny has a question. So is there any reason to choose to use a certain historic 30 years period? Should you continue to update each decade we move forward, or keep it the same through time?
Right. Okay, so that's something that we address in the guidebook. So the 30-year period that we use is really guidelines that come from the World Meteorological Organization, which will update that time period as decades go on. So we until recently used 1971 to 2000, and now we're moving to closer 1985 to 2005. We used 1960 to 1990 for a while in the past. So yes, the question I guess is yes, we as new models are being constructed as the new outputs are being provided, there is a switch from in terms of the historical period that we use. That said, so for example, we're also switching from SRES scenarios to RCPs, and we switch from using what were called CMIP3 models, CMIP5 models, so they're slightly different versions of the old models. It doesn't mean that the values that you are using with your old reference period are no longer good. It just means that the magnitude of the change may be slightly different, but it's not that you should throw everything out the window when we start using or when there's a gradual shift to that new reference period.
Okay, thank you. So we have some questions. I think Anne was the first one here. So Anne Cosmo writes, when our observed trended of emissions is higher than RCP 8.5 and no significant global action is reducing emissions, why use anything other than 8.5?
Good thing you didn't write that
one. So now I'm wondering whether I should take my Uranus hat off or I'll keep it on. And so we try to follow the guidelines that the IPCC put forward, which really say that at this point in time, all four RCPs, so even the lowest 2.6 and 8.5, are equally plausible. So at the same time, the IPCC also made a choice to promote or to ask climate centers to concentrate their efforts at the start on RCP 4.5 and 8.5, and if resources were available to then run 2.6 and 6.0, sorry. So if you look at the number of simulations available, you'll find that we have way more for 8.5 and 4.5 than for the other ones. We also, at Uranus, will tend not to give you RCP 2.6 unless you tell me that you're doing a mitigation measure. So there are studies, obviously, that show that in order to keep on 2.6, the measures that must be put in place are quite important, and it's going to be more than challenging to keep on that path. We are, as you say, most likely on the 8.5 path, but there's really no way for us to completely, for sure, say that this 8.5 is where we're heading. So there might be changes coming in the near future that will curb our emission scenarios enough to keep perhaps on 4.5 or even 6.0. So we still tend to give a range. So not just, and ultimately, also, I must say that it really depends on the time scale over which you are planning your study. So, for example, if you look at projections into the future, all scenarios, whether you use 2.6 or 8.5, or on the short time scale, so between 2050, they all say essentially the same thing. So there's not a lot of divergence in terms of temperature precipitation over that short-term horizon. The four RCP start to diverge really at 2050. So the horizon over which you're planning also plays a role in terms of which RCP you're going to pick. Does that answer your question?
Well, I think that's a great response. If not, Anne will let us know. She is typing. So we have some more questions here on the chat box. So I think next up is Jason Edwards, but this is a question from David Price. So what is your opinion on methods of bias correction as a way of overcoming the difference between observed data and biased model output?
So we use, so that's another topic in a guidebook. So we use bias correction quite a bit. You almost always have to do that. We also often use that because we tend to or users tend to want information over a small spatial scale. So think of global models which have a resolution of, let's say, 200 kilometers, maybe 100 kilometers now. That's still a very large grid cell for most users, and they want information over smaller grid cells, so let's say 10-kilometer. And so when we move from the 100-kilometer to the 10-kilometer grid cell, we do a bias correction using true observed values so that we remove the bias of the model outputs. And there are many different ways of doing that. The verdict, I don't think, is out in terms of which method is the best. It depends on many factors such as the variable of interest, the topography, the terrain, etc. But for sure, it's something that commonly used. There are two ways to present information. Two main ways. So you can show the delta, so the change between past and future, in which case you don't need to remove the bias because it's always constant. But if a user wants true future values, so for example, not the change in temperature, but the actual temperature in 2050, then you will have to do a bias correction with the observed to give them that information.
Okay, perfect, great. All right, so we have another question here from Harshan. So can you please comment on whether tools available in Canada and the US can be relied on for decision making by engineering professionals working on climate change adaptation projects?
That's a tough one. So, I mean, in terms of tools available, meaning climate information available online, I'm assuming that's what's being asked here in terms of tool. Is that?
I would.
Did I ask?
Yeah, because I think EPA's Create tool is an online tool.
So I think generally there are many tools available. The Environment Canada has great tools where you can visualize information. IDF curves. There's the loss reduction. What do they call? I could find it for you. They have a great tool for visualizing IDF curves. So, and I think more and more there's the tools try to outline, explain exactly which models were used, which RCPs, and more there's a tendency to try and explain to user what the information can be used for. So I think, and I think there's quite a bit out there. I can probably give you, if you email me directly, some specific examples of tools where data is provided in such a way that can be easily used in an adaptation framework.
Okay, great. That would be very helpful. Okay, so the next question is from Sarah Fraser. So I really like the key messages for interpretation. I might be tempted to use these key messages for other areas of science policy integration. Would you have any words of caution for the application of these key messages for other?
So key messages, okay, so let me remind myself of what I said. No, I think, well, the key messages that I show here, I think would be applicable to any domain, any sector of interest that's using climate information. They're really based on the type of information that is given, so you have to be conscious, and that's what we try to show in the guidebook, is you have to understand if you're only using one RCP, if you're only using data that's been averaged over a large area, if you're using very specific versus very broad information, what can you and can't you do with that information? So I think it'd be applicable to really anything where people are using climate information.
Perfect. And Anne as well shared a link to a tool for her shop.
Oh yeah, great.
Perfect. So I'm going to jump over to the conference call line to see if there's anybody that has a question that would like to ask over the phone. If so, go right ahead. And while we're waiting, if anybody has any more questions via the chat, just give it a couple more seconds. Okay, well, Katrine has a question over the chat box. So we're all aware of the difficulty in communicating climate change to people due to the inherent uncertainty. Can you speak a bit about how the guidebook addresses that?
Yeah, so we're assuming in the guidebook that people who are interested in it already have an understanding that climate change is occurring. So we're not speaking to people who still aren't sure whether this is a problem or not. We're just going with the fact that it is an issue and it needs to be addressed. But in terms of the uncertainty, we try to show what goes into the uncertainty in terms of the climate projections. So we talk about the main resources of uncertainty. So if you're projecting climate information into the future, you'll have uncertainty because of the natural variability in the climate. So no two summer is the same, no two winter is the same, for example. There's also the uncertainty associated with the emission scenario. So as we talked about before, it's hard to know which RCP we're going to follow into the future. And we also talk about the fact that there is uncertainty associated with the models themselves. So that's as far as we go in terms of explaining uncertainty and really trying to make a case for the fact that there's no one good answer. You really have to look at a range of plausible futures, but there are ways to try to pick and choose or limit the number of simulations that you will use in an impact study, for example. But it's still it wouldn't be for trying to convince people that climate simulations are excellent and are great, and you should be just using them all the time. So not necessarily for the general public or very what's the word I'm looking for? Simple, I would say, I guess, for lack of a better word.
Perfect. Okay, thanks. Okay, I don't see anybody else typing at the moment, so I'll jump one last time to the conference call line. Last call for any questions over the phone. Just hit *6. Okay, and last call for questions via the chat. I know we have some time, so if somebody's thinking of a good question, I don't want to cut us off. Okay, well, if that's the case, I guess we'll wrap things up here. So thanks everybody who joined us today for the webinar. You enjoyed it. And obviously a very, very big thank you goes out to Isabelle for your time and effort and for a great informative presentation. Are there any last comments from you before we sign off here?
No, I just want to thank everybody for being on the call, and please don't hesitate to get in touch with me if you have other questions or if you read the guidebook and have comments. We're really looking to improve on this resource. So if you have anything that you think is missing or that could be improved upon, please get in touch with me.
Okay, great. All right, well, thank you everybody, and have a great day.